Welcome to Reason VR. In this video we're going to consider use of VR in the oil industry. Why would we use VR in the oil industry, you may ask? That's easy. Building and running an oil rig involves huge costs and huge risks. Getting the design of a rig correct can save millions. So can being able to train people to spot potential problems and deal with them before they turn into something nasty. In the worst case, a disaster could cost many lives and hundreds of millions or even billions of dollars. So, even seemingly small changes can make a huge difference. However, training people for problem scenarios is extremely difficult, if not impractical. Nobody is going to cause large-scale damage to oil rigs for training purposes. It's just too expensive. Indeed, lots of people will go through their entire career and never have a problem with a well. VR training helps to prevent real problems occurring during rig operations and prepares people to deal with the problems that do occur. Here's a couple of videos from BP which illustrate these points.
This training guarantees that they will have that situation. And by having that situation, they'll go through the procedures, they'll go through their checklists, they'll make their phone calls, they'll feel the pressure, they'll feel the dynamic tension between what's going on the rig floor and the bridge, and they'll have the confidence to know how to handle that situation. They're building the muscle memory to handle these emergencies, so they go, I know how to do this. I did this in the simulator. I made this mistake in the simulator. I'm not going to do it again out here in operations.
When I fire up this simulator, it comes alive. All the gauges start to move, the lights start to flicker. If you open or close a valve, pressures change. It's as if you're on the rig. We drill, particularly in the offshore world, in extremely deep water environments, and the pressures involved are tremendous. And therefore, we want the people out in the field drilling the wells to have the best training possible. All right, so we're up and running now, so we should be good to go. Keep coming, there you go, half a foot. The reason we have this drilling simulator is we want the people on the rig to be prepared in the event something were to happen. They know exactly what to do to get us back to a safe situation. The element of surprise is actually one of my tools. I let them get comfortable, and then I throw a problem to them. They recognize it, they do the proper thing, and then I introduce another problem. What I'm really watching for is how they react. Are they calm under pressure? They've got to communicate, they've got to look out for one another, they've got to share information. To me, this is no different than military or commercial airline simulators. The value of all of this is to give them practice to make the competencies of the people that work for us that much higher. My desire is whenever people leave this room, if they're ever in the field and they see a problem coming up, they'll say, I've done this before. I know exactly what to do.
Considering the design process now, I'm quoting Brian Lozes, VR director at Audubon, a company specialising in providing VR services to the oil industry. He said that VR solutions provide significant advantages over traditional 2D and 3D models because they enable us to fully immerse operators and stakeholders inside the digital representation of their facility. He said that we can evoke the sensation of physically walking through the plant without ever leaving the desk. Digital twins are used to enable VR training. A digital twin is a standalone, interactive 3D model that gives operations personnel the capability to walk virtually the deck of a rig and to familiarise themselves with a fully constructed version of the top side of it, without ever leaving the office. This digital twin method was used by Shell to help with the development of its Vito oil rig. A digital twin also serves as a useful tool for developing emergency evacuation plans, determining egresses and identifying potential health, safety and environmental risks, which is often not feasible with traditional 2D and 3D non-interactive models. Additional features from Audubon include multi-user capabilities, which means that team members can jointly complete tasks, take action, and communicate just as they would in a real-world scenario, regardless of geographic location. In addition, full-scale digital cranes or equipment can be inserted into a virtual environment, allowing the user to verify dimensions and determine if objects or pieces of equipment will introduce problems spatially. Consequently, stakeholders are able to make design adjustments or plan interventions before arriving on location. In many cases, this directly translates into cost savings by reducing the likelihood of late-stage field change orders, which also often lead to costly project delays. Shell's Vito platform reached the final investment decision point in April 2018 and will be Shell's 11th deepwater host in the Gulf of Mexico. The project features a low-cost development approach aided by VR design and therefore has a competitive forward-looking break-even price, which is estimated to be less than $35 per barrel. Finally, let me mention smart glasses, as they are a great additional benefit for ongoing operation support on a rig. Someone undertaking work with smart glasses can get augmented data and instant remote expert backup because a remotely positioned individual can see what they are doing. Here's some video from BP demonstrating this.
Using augmented reality so engineers in the field can share data and get expert backup in the blink of an eye.
That's all from us for now. See you in another video or take a look at our website at reasonvr.com.